This presentation is going to cover some of the technical details on progressed declinations and the lunar declination cycle. So here is an image of the Earth with the line around the middle being our celestial equator, and the green space is measuring a northern declination. The red line is the ecliptic, the path that we see the sun travel, which is at an angle because the Earth is at an angle. It's tilted about 23.5 degrees. And since the Earth is tilted, then that declination stretches not just north but south. So in this image, the celestial equator is right in the middle. And that, if you ever heard the term right ascension, starting with the 0 Aries point, in other words, the spring equinox in the northern hemisphere, that is the measurement that's used going around the celestial equator, right ascension. Declination then comes off the celestial equator, either to the north or the south. So during the summer, you have the sun on the northern declination in the northern hemisphere, sun on the southern declination in the winter, and the reverse if you're in south of the equator. So here's another little detail showing it slightly differently. And you can see the right ascension there, and then the declination north and south. So it's basically, declination is a variation on latitude. Now, the moon will vary over an 18-year cycle, 18.6-year cycle, in terms of how high or low it is on that same declination path. Now, the moon has a 5-degree variance from the ecliptic, so it sometimes is going to get quite far over the solar bounds, and that's called out of bounds. Sometimes it'll be quite a bit under the solar bounds, but that's the minimum that it can reach in a year. Now, planets, when you have them at the same declination, they are rising in the sky essentially at the same point. So they're together, and that operates like a conjunction. If they are within 1 degree of each other on opposite sides of the celestial equator, then that is a contraparallel, like an opposition. So here's a little bit more vocabulary just to sort of, and images that just help see how that works. So in the one image on the upper left, when the middle line would be the celestial equator, and our astrological declination is then the 2 lines on either side of that, which we call the Tropic of Cancer and the Tropic of Capricorn. So that is what we're looking at with planets. And in ordinary declination or in secondary progressions, those planets are going to move as over time. And so they can reach 0 degrees, which is at the celestial equator, and that's a crossover because they're going from north to south or south to north. The out of bound planets are above that 23.5 degree approximate. And so basically, we don't do a whole lot of large variation with declination. We're looking for very close connections. Now here, if you mapped the sun's path over the course of a year, here you can see that path. So it reaches from 0 degrees, that's the crossover equinox point, so the spring equinox, moving up to the summer. This is from the northern perspective, northern hemisphere perspective. And you can see that many of the Wiccan celebrations, or the older pagan celebrations, were at a midpoint, at the same time, which basically had the same amount of light. So Beltane and Lammas were at periods before and after the summer solstice, but you have the day equal to each other and the nights equal to each other. And so you can see when it reaches the winter solstice, and you have Samhain and Imbolc, they would be relative to the solstices, the same position, but relative to each other, like Lamastasamen, would be in contraparallel. They are opposite each other in declination. And this basically repeats every year. Now the moon will change its declination the quickest. So here's just 2 years of the moon going from maximum north to maximum south, going over crossover, increasingly getting out of bounds. The moon has this cycle for 9 years. It gets increasingly out of bounds, and then it shrinks down and goes increasingly to within the bounds and to a minimum position. And here is collapsing that cycle. So this is 50 years of following the declination cycle of transits. And since they happen every single month, it really packs them in tight. But you can see that oscillation between peaks and valleys of how high the sun will reach. So somebody born in the mid 2030s will always have a moon that's within bounds. People born in the mid 2020s and mid 2040s will have the moon out of bounds during the solstice periods. Here is an image of what it looks like on a normal chart in SolarFire. If you want to look at declination, they have an option to just include it as part of the listings for the planets, and you can see the plus meaning those planets are north declination, the minus means they are south declination. And you can see 2 planets here for this particular period that are out of bounds. So Mercury and Venus are above the limits of what the sun can do. SolarFire also has an option where you can put it in a strip like you see here, and then you see the planets on the northern side and the southern side. So for example, at the top you can see barely Mercury and Venus above the 0 degree, the boundary lines here. That's the maximum, and the sun and midheaven being June 12. Okay, we're almost to the solstice, so the sun and the midheaven are very close to that boundary line that the sun will reach. And Pluto is on the opposite side, contraparallel. And here you see the dividing line for the solstices at the 0 degrees between Cancer and Gemini, Capricorn and Sagittarius. And so that Antisha, that idea of seeing planets that have equal light during the day and equal night, they are across. So you would go either direction away from that 0 point. And so planets across from that are going to be at the same Antisha point. If they're opposite, then we call it a contra Antisha. Don't really need to worry about Antisha at this point, unless you already know about it. But anyway, here's an image, another one that gives you a picture of what's going on. So we have what you see in a chart, the wrapping around the Earth that will happen around the Earth as it orbits the sun of the different signs of the zodiac, the stars that create our own pathway. We've got the solstices and the ecliptic plane that the sun is traveling on, while the Earth is on its slightly tilted perspective. And then, of course, in the middle here, you can see the equinox and our Earth's tilt from that. So one of the things is that the moon will never be out of bounds when it's near the equinox. But if it is during a time frame where it can go out of bounds, it will happen in either Sagittarius, Capricorn, or Gemini and Cancer. Now, the other thing to know is that lunar declination is not in sync with your phases of the moon. So here you can see the moon moving along a declination cycle, and where the phases of the moon would occur during this month. So if we say this is for May, or June, I guess it would be for May, this one, you can see that We have the moon here at a first quarter, then a full moon, then the last quarter, and then a new moon. And so it'll be just slightly off sync with every cycle. Now, one curious thing to remember that's kind of fun is declination is measured by the sun. The midheaven and the ascendant are measured by the sun. So when you are trying to find out what is the declination for the midheaven and the ascendant, you would look at an ephemeris for the degrees, the sign and the degrees that that midheaven or ascendant is in, and you would find out what was the sun's declination on that day. And that's the declination for the angles. So it's totally tied in together. Now, one thing in SolarFire or different programs, you can get a graphic ephemeris showing longitude very easily. Do not mix that up with being latitude. Like here is a showing longitude, and it's collapsing the chart to just a quarter of its size, to 45 degrees. And just you have these straight lines. And those straight lines are the moving moon over the course of each month. And the lines that are going across are the natal positions. Now, if you do say, give me a graph at 45 degrees, you're only going to get basically the lunar phases. You are going to get the conjunctions, oppositions, the squares, and the sesquisquares and the semi-squares. So you can kind of see this maybe if you have a good enough monitor, that those are being shown as they have an intersection between where the moon is traveling by longitude, in other words, a normal transit in the chart, and then where the natal position would be. Now, around every 18.6 years, again, notice we're also talking about that nodal cycle, that lunar standstills occur when the moon reaches its most extreme. You saw from that previous graph how the moon went out of bounds for some time, and then it sort of it shifted, and then it went in bounds and stayed there, and then it went out of bounds again over the course of many years. That's its normal pathway. Well, at the end of that, at the extreme point where it's most out of bounds, they call that a lunar standstill. And that is quite high or low, depending on whether you're thinking north or south or extreme anyway. So if the sun can only reach about 23.5 degrees, or that would mean that the moon is a good 5 degrees higher north or south from where that solar position can be. So that is seriously out of bounds. That's the major lunar standstill. We had one in 2006, and we had one just not terribly long ago in the end of December 2024. And then a minor lunar standstill occurs when the moon reaches its minimum declination, that lower position that happens for around 9.5 years, but the lowest point it gets between when it's getting lower and lower and then starts getting higher and higher again. And that's about 18 degrees north or south. So if you have someone born when the moon was not out of bounds, and especially when it's during a minimum phase, then you will never see it out of bounds during the progression because there's just not enough time. On the other hand, if you have somebody born with the moon out of bounds, it's very likely that as the moon is shifting over the course of the life, it will go out of bounds again. Okay, so maximum north and south, that's the limit of declination a planet can travel. Moon is not alone in going out of bounds. Mercury, Venus, and Mars can all go out of bounds quite a bit. Jupiter, Uranus, Neptune, and Pluto don't go out of bounds hardly at all. They just get a little bit higher. And Saturn pretty much stays within that boundary line all the time. This all depends on how their orbit works on the plane of the ecliptic, whether how close it is to that. Eris or some of the other outer dwarf planets and planets in the Kuiper belt can have rather irregular orbits, so that they can be out of bounds for years and years because of that, the angularity of their own orbit. So it varies for every planet. Asteroids too can go out of bounds. Many of them go extremely out of bounds. And as I mentioned, the dwarf planets can be out of bounds for months at a time. Now, the moon's declination cycle, on the other hand, when it does go out of bounds, as you saw, it's a very, very regular pattern. So over the course of its cycle, it's going to go crossover maximum south, crossover maximum north on a very regular interval. Basically, that 18.6-year interval. So the basic concepts, we'll do another slide that goes into the interpretation a little bit more, but just to basically understand, parallel is similar to conjunctions, contraparallel similar to oppositions. You're going to use all your same tools, looking at rulership, looking at condition of whatever planet that is moving in that position, and what else comes with it, who else is hanging out around the same point. So planets that cross over, they're a little more vulnerable. Suggests that there may be sudden or dramatic issues according to the nature of that planet. Now, natally, that's not going to be quite so, that's something somebody works with all the time. But when other planets then cross that crossover position, it will trigger any planet there. Maximum north or maximum south, that tends to be, well, actually maximum north to south. If you're traveling from the north, you're crossing over to the south, that tends to trigger first house issues. And when you're, especially the moon traveling from the south to the north, tends to trigger seventh house issues. The planets that are maximum north or south, they're pretty stable. It takes a while to make that curve. So they suggest a little bit more stability, because it can be 3 to 6 years to make the full curve from going from the maximum north back down to south. And at the maximum north, there is a little tendency for it to be just like in the chart at the northern side, the 10th house issues, maximum south to 4th house issues.